Hello guys, I am Jagadesh with Durga Softwares. Okay, now I am going to discuss the topic LCM and HCF. Okay, least common multiple and highest common factor. Okay, before getting into this topic, you should have to aware of the multiple and the factor variation. Okay, suppose for example 6. Okay, 6 is divisible by 2 or 6 is exactly divisible by 3, right? So 6 is here, 2 is factor of 2 is a factor of 6. Okay, here 6 in 12 is multiple of 6. Multiple means 6 1, 6 2, 6 3 into 1 into 2 into 3 like that. Okay, 12 is a multiple of 6. That means 6 multiples is the 12s. Okay, and here 2 is a factor of 6 means 2 can divide that number. Okay, a factor is a number that can divide a particular number. Okay, so this is the major variation between factor and the multiple. Okay, suppose for doing this least common multiple and highest common factor problems, when you look at here, okay, we have two types of models. Here it is, first type. For solving the LCM problems, we have two types. First one, factorization, factorizing model, and second one, division model. Okay, we have two types of methods here, and here also we have factorizing method and division method. Okay, suppose here it is LCM of 24. Okay, I am giving you 24, 60. Okay, and suppose for example 1 or 24, 60. Okay, LCM for these two. Check it for this one. First one. Okay, 24, 60. LCM identification factorization method. In factorization method, you should have to write in factors of primes. Okay, so for getting the primes, you can have the method that is factors division method, 2 1s and 2 2s here. Again 2 6. Again 2 3s. Here factors for 24 is 2 into 2 into 2 into 3. Okay, and the same way factors for the 60 is, this is a factor division method. So 2 into 30. Again 2 into 15, that is 30. Okay, again 3 into 5. Okay, so here it is factors for the 60 is 2 into 2 into 3 into 5. Okay, here the LCM, for getting the LCM of that number, that common multiple should be counted as one time. Okay, least common multiple to those numbers is this common should be counted as single time. Okay, this common multiple should be counted as single time. Okay, that means here 2 into 2 into 3. Okay, and the remaining 2 into 5. This is the LCM for the numbers. Okay, so suppose here 2 into 2 4, 4 3s 12, 12 5s 60, 62s 120 is the LCM. Okay, and coming to the HCF factorization method, highest common factor for 24 and 60 here is, when you look at here, 24 factors is 2 into 2 into 2 into 3, and here 60 factors is 2 into 2 into 3 into 5. So here HCF is highest common factor. Okay, maximum, that was the highest common. Only this one is the common. Okay, so 2 into 2 into 3. That means 2 2 is 4, 4 3 is 12. So this is the HCF. That means while cancellating the 24 and 60, okay, only the HCF, that means 12 5s and 12 2s. Only that calculation must be available. Now other calculations is existed. That means that was the maximum cancelled number in that one. HCF means maximum common factor for cancel that one. Maximum common factor is only 12. That means while you cancel with the 12, you can get the 2 by 4. In next step, there is no another cancellation process. Okay, right? So the major variation for the LCM and the HCF is least common multiple. It's a multiple. Okay, so common and multiples which was common to those two simultaneously is 2 into 2 into 3 and 2 into 5. This is the LCM. One in general division, okay, in division process you should have to take 24 and 60. Here the LCM is you must have to take the common in both. Suppose 12, okay, 12 2s and 12 5s. So directly 12 2s 24, 24 5s, or 12 5 60, 62 is 120 directly. Okay, suppose LCM for 6, 12, 14, 20. Okay, for LCM these all actually 6 and 12 have the common 3. Okay, 14, 20 and 12 has the common. Okay, 14 here 12 and 20 has the common, that is what is that one? 4. Okay, but in LCM rule 1 is you must take that factor out only if maximum common in all the digits. Okay, here it is maximum in all the digits common factor is 2. 2 3s, 2 4s, sorry, 2 6, 2 7s, 2 10s. Okay, and what will be the maximum in all these 3? In all these 4, maximum common factor 3, 6. When you common the 3, 3 1s and 3 2s. Okay, when you common 2, okay, 2 3s and 2 5s. Okay, no other common factor. Okay, so you must have at least 3, or at least in other case you must have to take out only the common factors of at least 3 or at least 2 in the options of 3 common things. So here it is 3 1s and 3 2s, 7 and 10, and again 2 1s and 2 5s, 7 1. Okay, so here the answer is 7 5s 35, 35 2s 70, 70 2s 140, 143s, 14 3s what? Okay, 10 3s 30, 4 3s 12. That means 42. That means here the answer is 420. Okay, to find the LCM by the way of factorization, find the LCM by the way of division. In division, rules is common factor should be common in all the numbers, factor should be bring out. Okay, if in other case only in 3 numbers, if you have 4 numbers, only 3 numbers exhibit one condition. Okay, no other condition must satisfy all the 4, then you should have to common those 3 digits common number, 3 numbers common factor, then and bring out. Okay, and here while you common the 3 1s and 3 2s and bring down the same number at the next position. Okay, these are all about the LCM. And coming to factorization, HCF is the highest common factor, that is the highest common factor that can cancel the numbers. So it is a factor, that's a multiple, that's the major difference here. Here division, okay, by using the division, here our HCF divide the maximum number with divide the highest number or the higher number with the least number. So 24 60, 24 2s 48, okay, and here you have 12, and divide the previous divisor, divide the previous divisor with the remainder. Okay, 24. 12 twos 24. Here the remainder is 0. That means here the HCF is the 12. Where the remainder is 0, the previous divisor should be considered as the HCF. HCF for 24, 30 and 60. HCF for 24, 30 and 60, when you have three numbers, okay, first take out the least one and next 30. 24 ones 24, you can get 6. 6 and next get the previous divisor to dividend position. Okay, and 6 fours 24, here the remainder is 0. That means here 6 is the HCF in these two common. Okay, and based upon that HCF, you should have to divide with the next number. Okay, again it also satisfies 6, 10, 60, remainder is 0. That means the highest common factor in all these three is 6. Okay, this is most important thing, ma. This is most important thing. Okay, here factorizing and division, variations in HCF and division, HCF and LCM. Okay, and let's have a discussion on some of the problems in this one. Okay, suppose one question, if one bell, first bell rings after every 15 minutes, okay, and second bell rings after every 30 minutes. Third bell rings after every 45 minutes. Okay, then in how many hours they can meet, they can ring simultaneously? Okay, in how many hours they can meet simultaneously? At what time? Okay, in how many hours they can ring simultaneously? Okay, this is the questionnaire format. First bell rings after every 15 seconds. Second bell rings after every 30 minutes, and third bell rings after every 45 minutes. When they will meet, when they will simultaneously rings at the first time. Okay, when they will rings simultaneously at the first time. I am asking you, simultaneously rings at first time. Okay, when you check it here, what is the LCM for 15, 30 and 45? Before getting into the LCM, why we should have to prefer LCM here? Look at here. Here 15, for every 15 minutes first bell rings. Okay, 15 minutes, first bell rings at 15 minutes, 30 minutes, 45 minutes, okay, and 60 minutes. Okay, and here it is 60 plus 15, that is 75 minutes. Okay, here it is 90 minutes and so on. Okay, right. And the next one, second bell rings at 30 minutes, 60 minutes, okay, 90 minutes and 120 minutes. Third bell rings at 45 minutes, 90 minutes and here 135 minutes. That means which one is the common time they can meet at the first time? After 90 minutes, they can meet at the first time. If the first bell, if the total bells start at 8 o'clock. If the bells first at starting, they meet simultaneously at starting time 8 o'clock. Then after 8 o'clock, when they will meet at the first time, when they will ring simultaneously at the first time. Okay, after 8 o'clock. Then here what will be the answer? 90 minutes is the common factor. Okay, that means when you add 90 minutes, that means 60 minutes and 30 minutes. 60 minutes means 1 hour. So 9 hours and 30 minutes. They can meet simultaneously, they can ring simultaneously after every 1.5 hour minute. Okay, so this is the conclusion. So for doing this one, every time when I've wrote like this, that will be a time taking process. So then what is the LCM for 15, 30, 45? Okay, when I take the LCM, 15 ones, twos and threes. 15 twos, 30, 33s, 90. Okay, or sometimes you may do another way. Maximum number that can be exactly. Okay, here I will give one clue. Look at here clearly. Which one is the highest one? 15, 30 in 45. Which one is the highest one? 45 is the highest one, right? In maximum numbers multiples that can be common to all the number is said to be the LCM. That is the shortcut. Highest number multiple common to all. Highest number multiple common to all. Okay, is said to be the LCM. Highest number multiple, that means 45 ones. 45 ones is common to 15? Yes. Is common to 30? No. Okay, so 45 twos, 90. Is 90 is common to 15? Yes. Is 90 is common factor? Is 90 divisible by 30? Yes. Is 90 divisible by 15? Yes. Is 90 divisible by 45? Yes. That means the LCM for these numbers is nothing but the highest number multiple common to all. This process is very much useful to you in time and work process. At time and work and Python systems, where I can do the problems based upon this concept only. Okay, while getting the LCM, total units of work can be calculated. Okay, so LCM, for getting the LCM, we are doing the highest number multiple common to all as a shortcut. Okay, LCM what? Highest number multiple common to all. This is the conclusion what I have given to you. LCM is nothing but highest number multiple common to all. Okay, suppose I will give another example. So, what is the LCM for 6 and 12? What is the LCM for 6 and 12? Simply highest number multiple common to all. 12 ones 12. 12 is common to 6. That's why, so here LCM is 12. What is the HCF in these two? Here HCF is 6. What is the highest common factor in 6 and 12? Only 6. Least number multiple, that must cancel that factor. Okay, so 6. Okay, so 6 ones and 6 twos. That is the only the condition. Okay, so HCF is equal to 6. 6 into 12 what? 72. Okay, 12 into 6 what? 72. That means here two numbers product is equal to LCM into HCF of that numbers. Okay, let the two numbers be, let two numbers is equal to A and B. Okay, and the LCM and the HCF are the LCM and HCF of A and B. Okay, then two numbers multiple, A into B is equal to what? LCM into HCF. Okay, when you have the LCM and the two numbers, okay, you can get the HCF by applying this formula. Suppose for example in this way, A into B is equal to 72, if the LCM is 12, what is the HCF? 72 by 12. Same example. Okay, first number let it be, here it is 6 and 12. 6 into 12 is equal to LCM is equal to 12, then HCF is equal to what? 6. Okay, product of two numbers is equal to LCM into HCF of the two numbers. Okay, that is the conclusion here in LCM and HCF. Okay, right? Okay, now I will give some of the examples. What is the least number that can be exactly what is the highest maximum 4-digit number? Okay, I had already discussed in number system, maximum 4-digit number that can be exactly divisible by suppose for example here it is 24, 60, 180. Okay, maximum 4-digit number that can be exactly divisible by 24, 60 and 180. This is one model. Okay, this models is very important to you. Look at here, maximum 4-digit number that can be exactly divisible by 24, 60 and 180. That means first of all you should have to get the least common multiple of 24, 60 and 180. Okay, what is the LCM for 24, 60 and 180? Okay, so 180 into 1. Is 180 is divisible by 24? Is 180 is divisible by 24? 24 5s. 120. Okay, but not. Okay, 24 10s 240. Okay, so 120 240. There is no 180 there. Okay, 180 into sometimes you may do like this also, 24, 60, 180. Okay, common in all these three is 6 4s, 6 10s and 6 3s. Next, common in all these three is 2 2s, 2 5s and 2 15s. Next, common in all these two is 5 1s and 5 3s. Then you can get 2. Is there any common condition? No. So you can get the LCM as 6 into 2 into 5 into 2 into 1 into 3. That means 6 5s 30, 32s 60, 62s 120, 123s 360. That means the highest number multiple 180 into 2, 360. 360 is common to 24 and 60. So what is the LCM of these two? LCM of these three, 360. Then he asked the question, maximum 4-digit number that can be exactly divisible by that number. So 360, when you divide the maximum 4-digit number is 9999 with 360, you can get 362s. Okay, that is 720, 9 and 7 and here 1 and 9. Okay, 1700 something. Suppose 305s, 1500, 65s what? 300. Okay, 300 plus 1500, it's more than 1700. So you must take only up to 4s. Okay, 300 4s, 3 4s 12 and 4 6 are 24. It's a tens place, 400. So 1440. You can substitute this one. You can get the remainder 9 and here 5 and here 3. 359. Okay, when you subtract this 359 from 9999 minus 359 is equal to, when you subtract this one you can get 0, 4 and here 6, 9. 9640 is exactly divisible by all these numbers. Maximum 4-digit number that can be divisible by maximum 4-digit number that can be exactly divisible by 24, 60 and 180. Okay, so here first of all you should have to find out the LCM, least common multiple, that must be identified, and then with that LCM you should have to divide the maximum 4-digit number. If it leaves remainder 359, if when you subtract this 359, that number is exactly divisible by 360. Okay, that is the maximum 4-digit number. Okay, so this is the process which was dealt already in number system. This is already dealt in number system, and this was a new concept, LCM, at this position. Right, now suppose find the maximum 4-digit number that can be exactly divisible by 32, 45, 72 and leaves the remainder remainders 25, 38, and here it is 65. This is another important model. Okay, find the maximum 4-digit number that can be exactly divisible by 32, 45, 72 and leaves the remainders 25, 38 and 65. Okay, when you look at this one, you can identify the one thing. Okay, here it is, when you divide with 32, that maximum digit, it leaves remainder 25. Okay, it leaves remainder 25. Then what is the difference here? 7. Okay, when you divide with 45, you can get the remainder as 38. That means what is the difference here? 7. Okay, when you have 65, here the remainder is 72. When you divide with 72, you have the remainder 65. That means here also the variation is 7. That means if this 7 is added to this number, that is exactly divisible. That number is exactly divisible. If this 7 is added to this number, that can be exactly divisible. This 7 is added to that number, okay, to that maximum 4-digit number, that can be exactly divisible by these numbers. So when you add LCM of this, find the LCM of this one first of all. Okay, find the LCM of this one, and here you have the difference of 7. So when you add with 7 to all the LCM, that means get the LCM plus 7, then remainders is 0. Okay, so then go through the same procedure. Then what is the LCM for 32, 45 and 72? 32, 45, 72. Okay, here it is the 5 multiples, so you must check it for the 5 multiples of 72. 72 5s, 7 5s. Suppose check it for the 5s, 7 5s 35 and 5 2s 10. So 360. Is 360 is common to 45? Whether it is divisible with 45 here? Okay, check it for. Okay, 45 2s 90, 90 2s 180. Okay, 180 2s 360. So it is divisible by 45. Is it divisible by 32? Is it divisible by 32? No. Am I right or wrong? 32 5s, 32 10s, 320. Okay, 32 5s is not common to this number. Okay, that is not common to 360. So this is not common. So while checking for the 3 numbers, you should have to prefer the division process, but not the highest number multiple common to all process. So here what is the common in all these 3? In all these 3, is there any common one? No. So I can prefer, here it is third table for these 2, okay, 3 1s and 3 5s, here 3 2 6 and 3 4s, here it is 32. Now again it is 3 5s and here it is 3 8s, and here you have 32, 8 1s and 8 4s. Okay, so what is the LCM for this one? Look at here, first multiply the highest number with the 5, 8 5s 40, okay, 40 4s 160, 160 into 9, okay, 16 10s are 160, okay, 16 10s 160, then 16 9s are 160 minus 10, that means 150, 150 minus 6, you can get 144, okay, 14400. 69 is 144, 144, is the highest common factor, sorry, least common multiple. Then you can add this number. Okay, 1440 plus 7. When you divide the number with 1447, 9999 into 1447, okay, if it is 8 times 8000 and 4 into 8 32, and it is a hundreds portion, okay, and 4 into 8 32, and this is a tens portion, and 4 into 7, that is 28, then 8 4 5 and here it is 11. Okay, it takes more than the 4 digits. Okay, so you should have to prefer to 3 times. It is 7 times, 1447 into 7. Okay, so by the multiplication you can get the answer easily. Columnar process 0 0 0. Okay, 100 100 100 3 zeros, and at last 177. Okay, 4 7s 28, 4 7s 28. Okay, and again 7 7s 49. So you can get the answer 9, here 12, here it is 11, here it is 10. This is also more than the 9999. So you should have to prefer to 6 times. 1447 into 6, 1000 into 6, 6000. Okay,